Push the button.
Ready?
Oh,
Well, I heard this in third period. It's not really a joke. You guys will get it. Some of you.
There you go.
How many steers are born in the United States each year?
how many?
0.
Oh,
Because they're not born that
Yeah.
way. They get them chopped off later.
I get it.
boo.
I laugh.
Boo.
Grand people laugh.
That's just terrible.
That's not even like a fake laugh.
It's not even a joke, really. It's
That
a trick question.
Restart.
Cut that out.
Alright, I need to do
Joke,
Didn't too many
Do we need to start over?
What do you call a flying Jew?
Smoke? I know that was one.
You gotta cut that out.
Okay, no. Alright, here we go. Answer is 3 to the x. That's 3 to the what? 5th? 4th?
Fourth.
4th?
Fifth.
Oh yeah, I got it good.
Alright. So x equals 5. That's
X to the third.
3 squared to the x, which is 3 to the third. So 2x equals 3. So x equals 3 halves. That's, let's see, 3 to the third to the x equals 3 squared. So 3x equals 2. So x equals 2 thirds. Now let's see, that's 3 to the third to the x. And that's 3 to the negative 1, so 3x equals negative 1, so x equals negative 1/3.
Hey, I have a question on that one.
Huh.
Was I wrong in multiplying by both sides by 3?
Yes.
Yeah.
Getting a1 to the x?
Jump
I'm
out.
not
Yeah,
asking
because-
you. Getting 1 to the x equals 1.
Even if you multiplied 3 times 27 to the x, you wouldn't multiply those because you have to do exponents before you
Gotcha.
multiply. So you can't even do anything with that.
Okay. Good to know.
Improper use.
Improper.
That's improper use of that. That's only when they do something. Anyway, this is 2 to the third to the 2x minus 2. This is 2 to the negative 4th. Is that right?
Sure.
So that's 6x minus 6 equals negative 4. So 6x equals 2, so x equals 1/3.
Wow. It's 2 6 count.
2 6 because it was just
2 6, you left it like that?
It's the same thing. It's the same
Come on.
thing.
Come
It's the same
on.
thing. Come on.
Don't, you're not, no.
Don't make popcorn.
I'm not making it.
Okay, guys. You guys lost that
Way to go, Isaiah.
privilege. Let's see that, we can turn it into that. I think it's 2/3 to the negative third.
Yep. Yeah, I can use good memory.
So therefore x equals negative 3.
Ow.
How?
Wow.
That is 2/3 to the negative third.
Complicated.
Well, actually, it's 3 halves to the third. You should just see that one easily. 3 to the third is 27, 2 to the third is 8. But then to flip it, if you just make the power negative, it flips the inside. If you have a negative power on the outside of a fraction, basically it just flips the inside. Long story short. Ooh, these ones, now it's getting fun. Let's see, what's that? 3 squared to the y plus 1. That's 3 to the, it's up here, 5th. To the 1 minus 2y. So that's 2y plus 2 equals 5 minus 10y. So 12y equals 3 and y equals 1/4. Yeah?
Yeah.
That's 5 to the third to the 2 minus 3y, and that's 5 to the 4th to the y minus 3, so that's 6 minus 9y equals 4y minus 12, so 13y equals 18. 18 thirteenths. That's a nice problem.
I got a 21.
21?
I got 21 13.
9 equals
Couldn't tell you.
You tripping, Jack?
x is 2.
Joe must be on me. I am adored.
Did you add the 12 with the 9 instead? I don't know. That one,
X equals 2.
subtract 3 first, so it's 3 to the x plus 1 equals 27. Now it's easy. 3 to the x plus 1 equals 3 to the third, so yeah, x equals 2. Now here,
I was confused how you.
get them all to threes. 3 to the 5x times 3 squared to the x squared equals 3 to the third. Well, okay, so now that's 3 to the 5x times 3 to the 2x squared equals 3 to the third. Right?
Now you combine.
Now,
Combine 3.
when you multiply, what do you do with your exponents?
Add them.
Add them. So it's 3 to the 2x squared plus 5x equals 3 to the third. So therefore, 2x squared plus 5x equals 3.
Wait,
Minus.
why do you drop the 3?
Because if the bases are the same, then and it's an equation, the exponents have to be equal. If you got 3 to a power equals 3 to a power, the powers have to be the same. So you just say, hey, those are the same. Subtract 3 from both sides. 2x squared plus 5x minus 3 equals 0. Factor 2x. X plus 3, x plus 1. So x equals a half, and x equals negative 3. Yeah?
Yeah.
Great success.
Great success.
On their head. Wow, look at this.
Something we actually understand.
Let's see, that's 3 to the negative third. Well, that one was easy, because now it's already ready. 4x squared plus 4x equals negative 3, so x squared plus 4x plus 3 equals 0. So x plus 3, x plus 1, x equals negative 3, x equals negative 1. Yeah. And this one, yeah. What's the common base?
2.
2. So change them all to 2s. That's 2 to the third times x squared over 2 to the seventh. Thank you. I didn't know it in my head. And that's 2 to the negative 2. What do you do when you divide x with your
You
exponent?
subtract them.
Subtract them. So just go 2 to the 3x squared minus 7x equals 2 to the negative 2.
No, so from equal
So then 3x squared minus 7x equals negative 2.
to add
3x squared minus 7x plus 2 equals 0. So you got 3x, x, 2, that's 6, and 1 is 7, negative, negative. X equals a third, and x equals 2. Who got 100%? Holy smokes.
I missed all of them but the last one because it was dumb.
You missed all of them but
I-
the last one?
Only missed the last one. Got all of them but the last one.
I was like, wow, Henry. It's pretty bad. Yes. Jellica.
No, I did my memory.
Okay.
That's fine.
That other problem, I never even thought about it. Well, I did like at 10 o'clock last night when I was laying in bed. I was like, oh, yeah, there's that problem. And I started thinking about it just in my head. And I was like, I don't even remember what it looks like. I went to sleep. So, I don't know. Sit here and watch me try to figure it out, or we can just move on with our lives. Move on with our lives, yes.
Trying to figure it out. Trying to figure it out.
Oh, I heard two
Who
people
said
say.
that?
I heard two.
Who said that?
I don't even know how, honestly. I don't know what to do.
I
That's,
can't see what you're doing.
I'm not afraid to admit that.
Gosh. The honorable. Oh, ish.
I mean, I want that freaking thing to equal 0. I don't know. Well, you can multiply those. And subtract the x, or add the exponents, negative 1. 7 to the x plus 2 power. Let's see, this is what's messing me up right here.
Minus 7 the x minus 2.
Yeah. Minus 7 to the x minus 2. Because that'd be like negative 1 and negative 1 plus of that, isn't it? Okay. That doesn't help all of this.
You move that to the side. Right?
We can move some stuff to the other side.
Plus 2.
Which one?
The 2?
Subtract 2 to move to
Can you
the,
move the 2 and the 7x to the other
and
side?
then combine
Yeah.
all of these 7s.
I don't see how that helps. Now what?
Can you combine those 2?
Combine these?
Yeah.
They're not like terms. Wait, I got an idea.
Better question. Who
Got an
actually
idea.
wants
They're not
to
like terms.
solve?
You can't combine them. Because it's addition and subtract. If it was multiplication, I could add my exponents. If it was division, I could subtract my exponents. But when it's subtraction and you have different exponents, they're not like, that's like saying x squared plus x equals something. Like, no, you just leave it. You can't do anything with that. They have different exponents. I just had an idea though. Let's see what happens if we do this. See what I'm doing here? I changed that to 7 to the x times 7 squared. Because when you multiply with the same base, you add the exponent, so that's the same as that. Okay, you feeling it? You feeling it? And then, no. And then, what are we gonna do about that one though? That's gonna be like
Minus 7 to the x.
well, okay, 7 to the x. Shoot, I don't like the negative. It's pissing me off. Let's just go plus negative 7 to the x over 7 squared. Equals negative 2 times 7 to the x. Because that, you would subtract exponents and you would come up with that. Okay, but how does that help, you ask? Well, now we can get a common denominator. And we can add these together. And the common denominator would be 7 squared. And if I multiply that one by 7 squared, I get 7 to the x times 7 to the 4th minus 7 to the x equals negative 2 times 7 to the x. And then hell, let's multiply both sides by 7 squared. Why not? Multiply both sides by 7 squared. And you got 7 to the x times 7 to the 4th minus 7 to the x equals negative 2 times, and we can multiply those right now, and if you multiply, you add the exponents, so it's 7 to the x plus 2. Perhaps I should have left it.
Why are we doing this?
Because you asked for it.
No, he did.
Negative 2 times 7 to the x times 7 squared. I'm going to leave it like that. And that's, I'm going to factor that. 7 to the 4th minus 1.
Welcome to your tape, Alexis Laura.
Those are all multiplied.
That's why he's gonna kill himself.
Huh?
No.
Could you do that, like factor it? Where the negative, the side with the negative 2 could be factored?
The negative 7 to the x.
Welcome to the tape, Clay.
I have no more 7 to the negative 7 to the x. I factored it.
Could you factor the other side?
I was almost there.
That's a good sound.
Is that a good sign?
Lied.
Divide exponents to subtract.
True, but do I have to divide them both? Nope. Just one of them. See what I did there? That's good. I was like, when I divide, if I have two things multiplied together and I divide by a number, and one of them cancels, do I have to divide them both by that? No, it's just 6. So, that tells me I can just go that, well, you subtract exponents, so we get negative 2 times 7 squared. That's not good. It's not good.
There's no
What
x.
do you do with
That's
that
this far.
two? What do you do with the negative 2?
There's no x's left.
There's no x's left, that's not good.
Yeah, he calls it numbers.
The same thing.
So what's what? Thanks a lot.
Those aren't
Thanks a lot. We found an equation into the equation.
So,
Not true.
I'm gonna work on that. I'm not gonna.
What's this, the book that
I'm gonna refrain from looking up the answer, and I'm just gonna figure it out because something's wrong up here.
You're coming with like 5 pages of notes on it.
This was a genius idea, though. I just thought of it right now. Break. Sorry, this is on video for you folks at home.
Well, yeah,
Oh, that's
that's why I forgot about that.
Cut that out.
Yeah.
Okay.
Okay. Let's talk about logs.
They're made out of wood.
Did somebody
Used
say
for a lot of
unedited?
Logs. Yeah, you know what logs are?
They're brown pieces you sit on.
Shoot, I was worried about that.
Brown
Well,
pages.
yeah, I did.
Yeah, brown pages you sit on.
Oh.
I don't know how to put it in the calculator.
Did it bring this?
Oh, sounds like something.
Galen, you know about logs?
A little bit.
Like they're the.
No.
No?
I know how to put it in the
You know what it
calculator.
stands for? Or short for?
Logarithms.
Logarithms, yes.
Logarithmic.
Logarithms. It is the inverse of an exponential. Does that help?
Say natural logs.
You know what inverse of an exponential means?
Is that what the numbers on the bottom?
It's like, you know when you're solving an equation, you're like, yeah. When it's multiplication, you divide. You do the inverse. You do the opposite.
You do
When it's-
exponents, you do logs.
Yeah. The opposite of doing an exponent is taking a log.
So instead of like 2 times 2, which is 2 squared, it'd be 2 divided by 2?
No, you just did the inverse of multiplication, which is division.
It's gonna be the smaller one at the bottom, right? It's like log.
If you have, here, you're going to memorize this, and this will be your guide. If you have a number to a power equals another number,
Did you like the number?
it is possible to solve this equation for x.
Yes.
You use a log. And you go log. See, I always go like this.
Captain's log.
So it's this number to this power equals this thing. So it's
Log.
a to the power of x equals b. These are inverses of each
So
other.
then what's the log of A?
The way I always just remember it, I always draw this picture to my. I draw this. I put anything, put any numbers, but usually I draw that, and I go, hey, I know this little number down here gets raised to this power, and it equals this thing right here.
Huh?
What the truck?
Why do you do it so complicated?
Because to memorize it, to remember what order they go in.
Well, A and B come before X, so you know, that's easier.
Okay, but what about 5 to the x equals 14? And you don't have that.
So
Go.
log of 5.
Go.
Log of 5 to the 14.
Log, draw a log, and then I'm like, hey, I know this little number gets raised. I draw a log, and I draw an equal sign, and I go, this little number gets raised to this power. So this number gets raised to this power, and I get that.
Okay.
That's so hard.
So someone type in the log of 5.
So your calculator
Thank you.
won't do that.
It only do logs of 10.
Log 5.
It only does log base 10.
Yeah.
What does that
You're
mean?
getting the very short version. The base is this little number right here. And so, like, if you push log on a calculator, it's gonna assume that this is a 10. So the way around that, long story short, it's May. We don't have much time. You go like, you use what's called the change of base formula, and you go log of the big number divided by log of the little number, and you type that into your calculator, and you will get the answer.
And why do
What
you
the
do that?
Sputnik?
You did this last year. A
Yeah,
little
I
bit.
did. Stammer?
Yeah.
I mean,
And then we got
Dingleberry.
to natural logs. Would you call it natural logs? This is LN.
Staff infected Dingleberry.
Oh, yeah.
Jingle.
Dingle Fritz, is that what we call them?
Dingle Fritz.
Dingle Fritz?
It means you deserve to get slapped in the face with a trout. Dingle Fritz.
That's what it means?
That's what
Yeah.
Dingle Fritz means.
What's x equal?
Brickleberry.
I'll get my calculator out.
That's true.
Get your calculator out. You're gonna definitely need a calculator for this.
Where in tarnations is my lord?
That thing slapped in the face with a trout.
Why? Everywhere, kind of fishing with trout now. Okay, now cardboard.
1.63.
I heard somebody was already your number one, so I thought I'd
Would you do the little squiggly equal sign?
So finally for
Approximately equals.
Kind of makes up for the shortness of
Oh my god, look at little dogs and girls.
1.63973851
Would you do the little squiggly equal sign if it's approximately?
the squiggly line.
Hey,
That's what that means, right?
Yeah.
That's it.
it's tight, it's tight.
There's your test.
Ready for the test? Yeah, honestly, yeah.
This is a hard one.
Henry. Dude, go up.
You guys just said
I
you're
thought I
ready for the
said
test.
that freaking
Go up
baseball.
yourself, Henry.
What time?
I'm so lost.
Dude, I said go up yourself.
It's all about this, Angelica. It's all about this.
No. Yeah, I got it.
Okay.
I think. Let's try.
Take it else.
Solve for x. If it's already in log form, you switch it back to exponential form. It's all about switching between log form and exponential.
So this gets raised to
The little number gets raised to the number on the other side, and it equals the thing right there.
10 to the 6 equals x. Right?
Yes.
So 10 times 10
10 to the 6th equals x. I've solved for x.
1 million.
And if you just watch that with no sound, that makes absolutely no sense, but that's just how they work.
Did you say without sound?
Without sound, yeah. Like, oh, how do you do that? It's just, it's just this. Yeah, and we're not gonna, yeah, it's,
Oh,
it's
okay.
unnecessary.
Every time you do it with zeros, don't you just like add that amount of zeros onto the number?
10 to the 6th, yeah, would be.
Yeah.
You would add like
6
as long as
10
zeros
squared is
together.
100, so
Yeah.
it'd be just,
That's
it's a million.
Yeah, it's a million.
1 million. Okay, let's go one notch harder.
Mirror. Whoa.
So what are you gonna do?
It's 2 to the
Switch it
7th.
to exponential.
2 to the 7th equals 13x minus 2.
Yes.
Obvious.
2 to the 7th equals 13x minus 2, and then
That's 2.
add 2. What's 2 to the 7th plus 2?
130.
130.
Yeah.
It's
So
13.
it should be 132.
No, I mean 130.
Oh.
2 to the 7th is 128 plus 2. 130. Divided by 13.
X is
10.
10.
X equals 10. See, you got it easy.
Okay.
If Stanford 7's last year, my mind was blown.
Dude, yeah, dude. Like,
Well, I mean, we get craziness.
Well, I mean, Mr. Hopkins is a better teacher, so.
maybe it was just because I was ignorant.
Yeah, that's probably true.
Because he was a new teacher.
Yeah.
So you're asking me to be a teacher and you quit?
Yeah.
Yeah, because how did you go?
He was actually our football coach. That's why I never took him
2
seriously.
to the 7th is 128.
And then plus.
This one is not an equation. Not an equation. It's just simplify it.
Oh,
So you apply it and shoot.
Log.
Oh, so we gotta talk about like what logs mean just by themselves. I never even did that. So like, if you just have this, you know what that equals?
do log of 16 divided by.
Or do you know what that means?
I didn't say
It's
it.
2 to what power gives you 16? That's what that means.
Okay.
That means 2 to what power gives me 16? 4. Should be 4. And if you do it on your calculator, just to check, log of 16 divided by log of 2, yes, it's 4. So going back to this one, you do the inside first, and you go 3 to what power gives you 81?
4.
Or use your calculator. 9?
4.
You're a nine, right?
How'd you get four?
Log of 81 divided by log of 3.
Because 2 to the 4th equals 16.
No.
3 to the 4.
Oh, on the last one?
Yeah.
This 4.
No, she's on the last one. She said, how did you get 4?
2 to what power gives you 16? 4. Or if you check your calculator, log of 16 divided by log of 2, but it'll change the base formula. Boom. 4. So doing this, you would just go, oh, 3 to what power gives me 81?
When do we use logs at
4.
college?
4.
Oh, which one, Tanner?
Oh, so what's the answer
2.
here? 2. It's not 4? 3 times 3 is 9, times 3 is 27, times 3 is 81. The log base 3 of 81. Log of 81 divided by log of 3 is 4. Log of 4 divided by log of 2 will be 2.
When will we use logs percentage?
Never, Clayton. Never.
Electroengineering.
Never.
Just asking.
You should know this by now, okay?
Placement test.
Actually, natural log is used in business.
When would you use this?
Placement test.
It's used when working with big number.
Electrical engineering.
You know how multiplication and division
Are like the same thing?
are repeated addition and subtraction?
Yeah.
Logs are and exponentials are repeated multiplication and division.
So it's like addition and subtraction, and it's multiply and divide.
And then it's
log.
exponentials and logs. Yeah.
What's it called?
Googleplex? What's a googleplex?
A really big number.
Isn't that just like a family?
Oh, properties of logs? I don't know what we're gonna do with this. You guys wanna do properties of logs?
No.
Change the base there, and we're gonna do that. Just deciding how deep I wanna delve into this.
Not that deep.
Skimming the surface here.
I mean, we're pretty good with this.
Go some regular.
Cool.
You should know some log properties. They're pretty easy. I don't know. I'm just losing my
Let's just chill.
trust here. Race to achieve.
Race to achieve?
Race to achieve.
Yeah! Achieve final!
Yeah, let's do it. We still have a bunch of these boxes left.
It's about that time of year.
It's about
right?
that time. Look at all these kids. You got 3 kids, so let's do it. How about we make the teams already, huh?
We're never finished because you left.
I know.
Yeah, it was just race to achieve. We made our own little cars. And it took the entire rest of the year.
I was in Dominic's the year.
We had 6 teams last time, huh?
Or we can actually do that.
Pumpkin cider. Oh yeah?
Yeah.
It just said
Dang.
They're like NASCAR.
Throw back to sophomore year.
That car, so I had spikes jump.
I remember like we took off and then hit a wall.
Remember my revolutionary 2-spin transmission?
Oh yeah, you're too serious.
Killed people.
Oh, the 2-speed?
It just goes slow and bang.
Wait,
You
what?
think yours are really good?
I don't know.
Oh, he had 3 classes to dress in.
Yeah, I had 3 classes to work on it. I had a little bit of background knowledge of
Yeah.
how things work, and I was like, oh, hey.
You used to just go.
It just-
It was like a clear CD.
Never lost it. No.
Oh, we're
Remember
not
one
making
time
teams?
We're not really doing that.
Aww.
He was
Truly a joke.
Yeah.
So excited.
My heart dropped now.
He was so sad now.
Give it a thought.
He had all the teams ready to go. He was about to have a draft.
Okay. Properties of logs. These are fun. Well, here's just a little like brain teaser for you. The log. Don't use your calculator. You gotta do this one in your head. 73 1 equals
0.
Wow, Clayton's quick. 0. How do you know it's 0?
Anything to the power of 1 is 0.
No.
Yes.
No.
Because
they can't. Anything 1?
Or any
This means 73 to what power will give you 1?
0.
Yeah,
Anything to the 0 power is 1.
0.
Anything
73 to the 0 power is 1.
Janik was right.
There's Here's some properties of logs, though. These are not fun. Log base A of A to the x equals. See if you can fill in the blank. Think about it.
X.
X, yes.
Because
We can put parentheses around that to make
Yeah.
it easier. This is like saying A to what power gives me A to the x.
A
X.
or X.
A to the X gives the power of A to the X.
Here's a harder one. A to the power of log base A
What?
of x equals.
What?
Wait, whoa.
Log of A times X equals A? No?
Log of A to the X divided by log of A.
This one's
Just
hard
log.
to come up with.
A to the X.
Trying to think of a way to explain it.
You do the log
This-
root of
This is A to some power gives me x, right?
Yeah.
That's what this represents. So this thing is the power I raise A to. I raise A to get x. Does that make sense?
No.
It's improper English, but right? It's A to what power gives me x. That's this. This is the power that I raise A to get x as my answer. So now I'm going to take that and do A to that power. What am I going to get?
A to the X.
Let's do it with numbers.
Let's do it.
3 to the log base 3 of 9.
It's 3 times 27.
3, this means 3 to what power gives me 9? 2.
So it's 6.
So I'm going to do 3 to the 2 power, and I'm going to get
9.
9.
Oh,
Okay.
Oh, okay. These will always, these are like inverses of each other. If you have something raised to the log base of that something,
So if you find that
those
out.
cancel, it's just 9.
How was I supposed to
So
get
then that's
that?
A squared.
This is x.
What?
So it's whatever the thing is.
So whatever
Oh,
that
it's
A,
whatever x
this is the power that I raise A to get x is my answer.
so whatever.
And I'm going to take that and raise A to that power.
What
I'm
power
gonna
do you
get
raise
X.
A to?
to get A. You raise power.
I don't
to
know.
A to
You have a
the X.
ladder.
But whatever it is, now I'm going to raise A to that power and I'm going to get x.
So after you find that power out, you use it.
Hawkins, you can put in your
Just went black.
Almost done. The rest are easier. Not to understand why, but to memorize. Log base A of x, y equals, if you remember no others, remember these. Log base A of x plus log base A of y.
wait, what?
If you have a log and you have multiplication inside of there,
Oh, so it's just.
it's the same, it's equal to addition.
Oh, okay.
We're not going into y, it's just, who cares? It's really easy to remember. And guess what division is? Subtraction.
We got a test next period.
Yes.
Test tomorrow.
And there's one more property.
Hold on.
We'll put some numbers in there and we'll do some. If you have the log
Raised to achieve.
any base and you've got a number to a power, or this is the same thing, both of these
God bless you.
equal the power times the log.
God bless you.
Yeah.
Yep. You multiply, you add, you divide, you subtract, you got a power, bring it down in front.
Cool.
That's what you're going to need to remember to be able to manipulate some crap. So like an example of a problem
Gosh, started out like sneezing.
You'll get told stuff like, write as a single log.
No, don't do it.
And you have like log base 5 of x plus log base 5 over y minus log base 5 of 13.
They're all log base 5.
That could be written as a single log.
You can.
Ow.
Log 5x plus y plus minus 13.
No.
5
Okay,
of
log
x,
base
y.
5. Pay no attention to my capital and lowercase
Log
l.
5 of x,
Means-
y over 13.
Means nothing.
X, y plus 13.
No, it's over 13.
X, y over 13.
X, y over 13.
What the fuck?
That means to multiply those, that means to then divide by 13. That's how you would break it down into a
Is it
system.
just because it's the adding
here?
and subtracting?
Addition is the same. If you have logs and the bases are the same, and it's addition, you can just multiply those and turn it into a single log. If you have subtraction, you can just divide those and turn it into a single log.
Okay, I got you.
So like, you have log base 5 and log base 5 and it's addition, you could just make that log of base 5 of xy. Then you have subtracting, log base 5 of 13, just divide that by 13.
Which all the logs have to be the same base, though.
They all have to be the same base, yes.
Is there a way that you can manipulate the bases if they're not the same?
Change the base formula. So make it log of x divided by log of 5.
There's no homework tomorrow, right?
Tonight, there's no homework.
No, yeah, but for tomorrow.
No homework tonight, right?